One of the things that I've been wondering, that's a lie. I wasn't wondering. I just took it for granted. That's the better statements to say, is why do pointers have data types? And it's very interesting question, is that there's a good reasons for it. See, pointer points to an address. Well, that's also wrong, because pointer doesn't point to anything. Pointer is an address. It's a memory address. To be more specific, it's a virtual memory address. So it's fixed size, right? 64-bit if you're in a 64-bit architecture. 32-bit if you are in a 32-bit architecture machines, which they are very rare these days. So if I'm an address, the next byte is that address plus 1, right? So if I want to move to the next address, I just add plus 1. And you see, and that address, the next address, is supposed to contain some other value. But this is where the tricky part becomes. If I say I want to build an array, because that's how arrays work. Arrays are just pointers at the end of the day, right? So if I have an array of integers, short integers, that is 2 bytes each, right? Then that becomes a pointer to the first address of the first allocation of that address, right? Which is whatever value. Then what is that array sub 0? It's basically the first location. But what is a sub 1? It's technically is identical to saying p, which is the pointer, plus 1. In both cases, the p plus 1 and the array sub 1 will give you the second element. And you see, what we really did is, because we know that's a pointer to an integer, a short integer, p plus 1 is compiled to and translated to p plus 2 in this particular case, because the pointer we're pointing to at 2 bytes, so we need to jump by 2 bytes, right? So we're jumping by 2 bytes, right? Because that's the trick here. But if it's a normal integer, 32 bytes, that's 4 bytes. So every time you jump plus 4. So you can see that when you actually compile those things, if you compile your program to assembly, for example, just do GCC -S, it's fascinating. You'll see the actual instructions that adds 4 or 8 or whatever to the pointer. It's just interesting. Without knowing the data type, I have no idea what's the next value, right? Otherwise, you'll definitely be corrupting things. So p plus 1, in summary, does not mean give me the next address directly, the next byte. It means jump by oneness of where 1 is equal to the data type length, right? So plus 1 becomes plus whatever the data type of this pointer is. So it's like we're converting here. There is a changing transformation of what's happening. And similarly, you can have an entire structure, say socket, you're building a bunch of packets, right? And then have a single pointer, and then say, I want to allocate 100 packets worth of memory in one go. You say, malloc, go, allocate me 100 packets. So you would multiply 100 times the size of the packet, which is all the fields and basically the different data types you have. So you have an IP address, could be characters, 16 characters, a source IP, port, whatever, right? So you'd have like 40 bytes, right? Times 100, right? That's 4,000 bytes just in one go. Boom. Funny enough, it actually fits a nice virtual memory page. One go. So yeah, you would have that in one go, and then you have a single pointer points to the head of this thing. And then doing just because you declare that pointer as a pointer of sockets or packets in this case, P plus 1 will give you P plus 0 first is the first packet, P plus 1 is the second packet, P plus 2 is the third packet, and so on. Because P plus 1 is not really literally go to the next address. No, it's actually P plus 1 times 40. Does that make sense? And P plus 2 is actually not P plus 2, just jump 2 bytes. No, we jump 40 times 2, 80 bytes. So that's just the next byte. Because I don't believe in C, at least, there is a way to jump by byte. C compilers will look at the plus 2 and will see the operand plus, that you're actually adding it to a pointer, and it says, I know you're adding a pointer to 1, adding an address to 1. I really need to know what the data type of what you're pointing to, so I can know how many bytes I can increment for. I can't just increment by 1 byte. Of course, if it's a character, pointed to a character, then it's 1 byte, so you add actual bytes. Yeah. Of course, this is as opposed to allocating 100 individual packets, each with its own malloc, one by one, which has an overhead if you think about it, because you will have to free up one by one. And when you do a malloc, there's a header that gets added on the top of your memory. And that basically adds, of course, an overhead, because one malloc is way better than 100 ones, right? So of course there's like pros and cons on both approaches, but there's a lot of overhead incurred by allocating memory for each of those packets or data structures. That's why object-oriented programming has a massive overhead, because you're kind of doing new, and we're really not thinking about it. You're doing new objects in a loop, and then in each of these loops, you're creating an object and destroying it and creating it, destroying it. So there's a lot of thrashing. And I think just appreciating how memory works kind of makes us think twice about what we're writing, what code we're writing. I thought I'll just share that.